Welcome back. So now we are going to take a look at the OS architecture, and there are three major platforms like Android, iOS and Windows Phone as of now that I want you to concentrate because the market itself consolidated to these three major platforms because Symbian is faded away, and MIDP Java phones maybe for another year it will be there, but maybe it will also fade away. So these top three platforms right now gaining momentum, and so it will be good that if we take a look at the architecture of Android first. So in front of you I brought Android architectural diagram. You can find this in Google, or you can find this in android.com itself. This is the same picture I am just using in this PowerPoint, and if you watch closely, the applications take the top portion, where home or contacts, your phone book, and browser, for example Android native browser takes because these are all the applications, and the rest of the all other applications like maybe Opera browser or Nimbus WhatsApp or Runtastic or Temple Run, any other application is there in the top. And then if you go below, the application framework take part. So activity manager in Android, everything is an activity. So for example, if you are a Linux user, you might have heard that everything in Linux is a file, and you write into the file and you read from a file. This is how Linux is being described. So in Android, everything is an activity. So you tap on something, it's an activity. You navigate somewhere and you drag and drop and you touch, you scroll, and you pass certain events. Everything in Android is an activity which you see in your LCD screen and you interact with is called an activity. And everything that take as a backend, like a backend process, is a service. So Google gives you comprehensive documentation about what is an activity and what is a service. So you should really take a look at that. You should Google it, and what is an activity and how it's said that it's an activity, and what is a service. And then there is package manager, which is you have different packages in your Android phone. A package is a set of classes and different files associated with that. So for example, if you have an Opera browser in your mobile, Android mobile, it's com.opera, for example. Though I don't know exact package name of Opera application, so it should be starting with com dot that package name. And you have window manager, and you have content providers, and you have view system, and you have telephony manager, your call logs and your phone book. You have resource manager, different resources, different icons being managed by resource manager, and location manager, for example GPS and all that. notification manager. If you receive a push notification, you have a notification area. If you scroll from the top portion, from bottom, you will reach the notifications, and it's been managed by notification manager. And this is a framework of applications. And then you have libraries. There are different libraries. For example, if you see, WebKit is a library. This WebKit, what is WebKit? And WebKit.org will give you more information. But WebKit is a browser engine, and surprisingly, WebKit is being used by Apple as well. I will be able to showcase you in the next slide. And OpenGL, OpenGL is Open Graphics Library. ES says Embedded Systems. OpenGL org can give you more information about OpenGL, because these libraries being open, Android make use of it, and then it render elements, graphical elements using these libraries, which is much better than they write their own graphic libraries, because being open, developers can make use of it. That is the meaning, true meaning of OpenGL. And Media Framework SQLite is the database. You can also Google it. SSL is the Secure Socket Layer libraries, where when you transmit your data in SSL, it will make use of these libraries. And Surface Manager. So these are the libraries. And you have Android Runtime, and in that you could see core libraries, and you have Dalvik Virtual Machine. Dalvik Virtual Machine is the same as your Java Virtual Machine, JVM. This is DVM, and it will act the same way your Java Virtual Machine acts. And for example, if somebody need to run an Android application in away from Android OS, so for example, BlackBerry brought Playbook, and they said that you can run directly Android applications in BlackBerry Playbook. What it mean? And so they ported the Dalvik Virtual Machine in there in the Playbook, so that Android applications can make use of that and use that virtual machine to run their applications. This is how it goes. And below that, Linux kernel, and you have display drivers. In order to display something in the LCD screen, you need drivers for that. That is how it will the display will talk to the programs. So you need drivers for it. So for example, if you have a mouse, and then without mouse driver, you cannot move the mouse cursor. So this is how it goes. So I have the drivers of that interact with my hardware. The same way Linux kernel gives you the camera drivers and the flash memory and the audio drivers and the Wi-Fi driver. For example, VPS applicant is the Wi-Fi driver, and the keyboard drivers, keypad drivers in here, and the power management. For example, power management need a chip that goes with the as a hardware, and then it manages the power management drivers manage the power management. For example, your Wi-Fi chip in the mobile, in the Android mobile, need 12 volt, and your Bluetooth chip and SD card need only 5 volts, and the power management chip will supply different voltage to the different hardware. For example, if your camera needs more power, for example 12 volt, your power management chip and associated drivers will take care of that. That is how it goes. Every time there is an Android update, they pick up the latest Linux kernel and then feed in there. So this is how the Android releases the latest versions. So I'll show you the iOS architecture now, and you could see the Apple applications and third-party applications in the top. Apple applications is the Safari browser or the phone book or the settings or any other application that the OEM itself makes is an Apple application. Any third-party application, for example, Opera, Nimbus, WhatsApp, Runtastic, Temple Run, running with friends, any other app or game or any third-party applications called third-party applications. The application that made by other company away from the OEM is third-party application. So that goes in the top, and you have UIKit framework and the foundation framework made by Cocoa Touch they call, and there is again OpenGL ES, which is Open Graphics Library, Embedded System, Core Graphics Libraries, Core Audio, OpenAL, Media Player, for example, when you're playing the media. So they split it like applications, and then the framework, and then the media, and the core services like SQLite or XML support or network support, for example, Wi-Fi, etc. And foundation libraries and an address book which is integrated there. You have then Darwin as a core OS and the virtual machine. So the system utils, and from there it will directly interact with the hardware. So you have the kernel space with core OS and system utilities such as drivers, and the user space where the frameworks and other applications go with. This is how the iOS architecture look like. This is Windows Phone architecture. The Metro UI, Windows Phone UI, for example, if you are taking a look at Windows Phone 8, so the UI is Metro UI, Windows Phone Metro UI, and you have XAML and HTML CSS in the view system, and you have model controller like JavaScript. Chakra is their version of JavaScript, C#, and VB, and C++ are inside the model controller, and WinRT APIs, and then they have communication data, graphics media, and devices and printers, meaning that those drivers, and they have application model in the backend, and these are all called system services. And below that, Windows Core OS services, the operating system services like interacting with the Wi-Fi driver, interacting with the Bluetooth, and interoperability with the different apps, and the call handling so happens here in the Wi-Fi in the core OS services. So being a mobile tester, you must know what actually you are dealing with. So for example, if you are opening a browser and looking at a web page developed recently, and you need to test it, so from which are all the devices you will pick up? You have a top 3 smartphones. Your web site goes to top 3 OS, so you can test your app either Android or iPhone, because they both share the same rendering engine called WebKit. So testing your mobile web's rendering ability in both Android and iPhone is pointless, but if you test it with Windows Phone having a different browser rendering engine, and then iPhone, that helps. So being a mobile tester, you should know what actually you are dealing with, so that you will be able to strategize your mobile testing activities. That is why I gave you this small introduction about mobile architectures. You will be able to read more about each architecture If you have time, you should read that. And being a mobile tester, knowing the architecture is important. So I just gave you a small introduction about that. You will be able to know more when we move on to the different sessions. Thank you.